In this video, we're going to look at the sum and difference of two squares. That's a very common type of factoring that you will need to do. However long you stay in math, factoring is something you do pretty much every semester and every course. So let's get started with this one. And this one is talking about the sum and difference of two squares. So let's talk about the title. So the sum means to add two squares and the difference means to subtract two squares. And looking at this x squared, which says it's a square, and 16, which we know is a square because it's 4 times 4, there's a pattern to these. Now, what we've learned so far is this type that says what multiplies to the end number and adds to the middle if the lead coefficient is a 1. So we can kind of think of this as x squared plus 0x minus 16. So the question would become what multiplies to a negative 16? 1 and 16, 2 and 8, 4 and 4. So it multiplies to a negative 16, so they're unlike signs, they're opposite signs, and it adds to 0. Well, negative 4 and plus 4, or if you want to say plus 4 and negative 4, those would multiply to negative 16 and add to 0. So it's x plus 4, x minus 4. Now that's the same exact thing as if you had written x minus 4 times x plus 4. I guess it's not exact because they're not exactly matching, but they have the exact result. So it's like 2 times 3 is the same thing as 3 times 2. It's a commutative property, right? So x plus 4 times x minus 4 is the same thing as x minus 4 times x plus 4. I have a tendency, but not always, to write the plus one down before the negative one, and some people are the reverse. It doesn't matter, that it's the same answer. All right. Now, so we initially looked at this and said, okay, what multiplies to 16 and adds to 0? And we're going to do another one kind of like that, but there's a pattern here. Do you see how we had the difference of two squares? We had x squared. Well, the square root of that is x, and that went here and there. And then the square root of 16 is 4. So we had a 4 here and a 4 there. So we're using the square roots of the squares to make the pieces of the factors. And these factors are binomials, right? Because there's two terms in each one. So we have two terms in the first factor, two terms in the second factor. And the only main difference between them, because they both have an x and a 4, is that one of them is plus in the middle and the other one is minus in the middle. And they call that conjugates. Okay, so conjugates have the two outsides are the same, the x and the 4, but the middle sign are opposites. Okay, just get used to that phrasing. So you can always check these. Remember that when you're factoring, you can always sit here and go, okay, what's x plus 4 times x minus 4? So it'd be x squared minus 4x plus 4x minus 16. And sure enough, the middle term drops out and you have x squared minus 16. So when you factor things for homework or tests, or you're factoring something so that you can do another process, you should take a minute and re-multiply it out to make sure that you're correct, because it just saves you all that partial credit and you're going to be looking for points maybe at the end of the semester. So try to save points at the beginning or the middle or wherever this is in your semester while you go along. All right. Now, let's remember where we were. So what we had is a list that's going to be attached to this video that says these are some steps, which if you follow that order, seems to do pretty well, okay, for my students, for not missing anything. Now, you may have your own list in your own order, and that's totally up to you. But if we go through the list, it would be, is there anything in common to factor out between a 4x squared and a 9? No. Is a lead coefficient of 1 is a trinomial? No. Is it the difference or sum of two squares? Yeah. 4 is a square, x squared is a square. That's kind of my clue. 9 is a square. So this is the difference of two squares. All right. So what we would have is we're going to go, okay, I think it's that pattern where we have the conjugates, where we take the square root of the front term. So the square root of 4x squared is 2x, and we put it in the front. And we take the square root of the back term, which is 9. Don't take the minus 9, just take the 9. And the square root of 9 is 3, and we put it in the back of each one. And one of them is a plus, and one of them is a minus. And if you're not sure you agree with that, right, let's multiply this out. Now, the other thing I want to show you is, this way is sort of the FOIL method for multiplying to, the FOIL, F-O-I-L, first, outside, inside, last, or the distributive property. This is the vertical method. So if you're using the vertical method, it looks like minus 3 times 3 is minus 9. Minus 3 times 2x is minus 6x. Just like when you multiplied in elementary school, 2x times 3 is 6x after you skip a spot, and 2x times 2x is 4x squared. And you add and see how that falls out. All right, so you should always take a few seconds and check. All right, let's try another one. This isn't too bad, is it? All right, and it would say factor. So if it asks you to factor this, you should start at the beginning. Is there anything in common to factor out? No. 181 don't have anything in common, and there's not an x in every term. It's not a trinomial with a lead coefficient of a 1. Is it the sum or difference of two squares? Yeah. 100's a square, 81's a square, x squared is a square. So this is the difference of two squares. So we're going to do conjugates. So the square root of 100 is 10. We put that in the front. The square root of x squared is x. The square root of 81 is 9. And one of them is plus and one of them is minus. So we see the pattern? All right, so I'm going to put one right here, and I want you to, once I write it, okay, I want you to stop the video, and I want you to run through your little list of questions and come up with an answer, and then restart the video so that you can see how you're doing, okay, kind of get a self-check. So here's the problem, and I want you to stop the video and get an answer, and then start it back up. All right, now, so when you did that, you would look at this and go, oh, all right, is there anything in common I can factor out? Oh my goodness, there is. There's a 16. So that would be x squared minus 4, because 4 times 16 is 64. So we'd have 16, and this x squared minus 4, there's nothing else in common. It's not a trinomial with a lead coefficient of a 1, and it is the difference of two squares. So I have two factors that are conjugates of each other. So the square root of x squared is x, goes in the front of each one. Square root of 4 is 2, goes in the back of each one. One's plus and one's minus. Now this is fully factored. It's possible that if you didn't ask yourself if there was anything in common, because you skipped that step, you would say, oh, hey, difference of two squares, which it is. And so what's the square root of 16x squared? Square root of 16 is 4. Square root of x squared is x. Square root of 64 is 8. And one's plus and one's minus. But if you had marked that and said that this was complete, it's partially factored, but it is not completely factored. Because do you see how there's a 4 in common in these factors, right? So from the first term, you could factor out a 4, and that would leave you x plus 2. And from the second term, you could factor out another 4, and that would leave you x minus 2. And these two 4s make 16. And now it's fully factored. If you had stopped right here, you would have partial credit taken off. Okay? And if you're doing computerized homework, it probably just says, no, that's wrong. All right, but if your teacher's grading it, they probably just give you partial credit because you're only partially to the end, right? So this little part about is there anything in common to factor out can save you points if you'll train yourself to be sure and look for that at the beginning, all right? Now, it's possible that you did this and you went, oh, yeah, there's a 4 in common. But students tell me that when they don't get the common factor out at the beginning, they often overlook it because they're so focused on, I take the square root, put it in front, put the square root of the back, that they don't notice that there's still something in common left. So be sure that, if you put it at the top of your list of things to do, it would be really helpful. All right, let's look at 50x squared minus 162. And what's the first question we should ask? It should be, is there anything in common to factor out? Well, while I'm looking for that, it would be really nice if they were 2 squares, because that x squared makes me think that maybe it's a difference of 2 squares because I've got a difference in two terms there. They're both even, right? So maybe a 2. Let's try a 2. So that would leave me 25 squared, because 2 times 25 is 50, minus, and 2 goes into 162, 81 times it. Oh, that's good. All right, so 25x squared is a square, 81 is a square, so that looks good. So I'd have 2, and then I'm going to have my conjugates, and the square root of 25 is 5, square root of x squared is x, square root of 81 is 9, and one's plus and one's minus. Turned out to be pretty quick, huh? All right, let's do another one, but this one's a little weird looking. Okay, so let's look at this one, and you go, well, okay. Well, this right here tells you it's a square, whatever is going on in this problem. So when you see unexpected, I won't say weird, okay, when you say unexpected problems on your test, your homework, or whatever, just say, okay, wait. They would be asking this if I don't have the skill set for it. So let's think, it's the difference of 2 things, 9. Okay, wait, it's the difference of 2 squares, because the square right up here kind of gave you a hint as to where you might want to go. Now, granted, it's a little weirder looking than normal, but I did say weird, didn't I? All right, but it's a little bit more unusual. Okay, let's try not to say weird. All right, now, what's the square root of x minus 2 squared? X minus 2. What's the square root of 9? 3. So we're just going to do our rules, even if we're kind of like amused or put out, okay, as to what this is doing. And one's plus and one's minus. Okay. Well, let's look right here. These parentheses right here are just something that we used to denote this quantity here squared, but since I'm not squaring it, it's just itself. It's just x minus 2. So this really is x minus 2 plus 3. And x minus 2 plus 3 is x plus 1. And x minus 2 minus 3 is x minus 5. I didn't make a match. I don't know about you, but that's just, I'm not sure I'm buying yet into this concept that this up here is obtained from x plus 1 times x minus 5. So let's do a little checking here a second. If I took this x minus 2 squared minus 9 and I actually multiplied this out, I'd have x minus 2 times x minus 2. X times x is x squared. X times minus 2 is minus 2x. Minus 2 times x. Minus 2 times minus 2 is plus 4. Minus 9. So I'd have x squared minus 4x minus 5. Okay. Now this is a trinomial with a lead coefficient of a 1. This was done in an earlier video. What multiplies to negative 5 and adds to negative 4? Well, the only factors of 5 are 1 and 5. And if I want a negative 4, it's a negative 5 and a plus 1. Oh, well, okay. These two things do match. So even though it doesn't look like this right here yields that, but it does. Now, one of the things you can do to help yourself get adjusted to something if it's kind of like leaving you a little cold is if if you do a problem like this and you work down here and you get this answer that's kind of like unexpected, okay, then what you need to do is either take this and multiply it back up to here and see if it gets you the same answer, or if it's an unusual form like this, work it out, get its answer, and then see if they match. Okay, but if you'll kind of complete that loop somehow by either multiplying up to the top or kind of working your way back down to the bottom again a different way, your brain will actually sort of settle into this faster and go, okay, yeah, all right, I'm not going to sit there and subconsciously worry about this little tidbit that didn't make any sense because now I kind of get it. So anything you can do like that, it may sound kind of silly to you, but trust me, anything you can do to get the brain to kind of stand down and go, okay, yeah, all right, weird, but I keep saying that. Okay, unusual, but okay. I guess there's nothing wrong with weird. I just was going to try not to say that today. All right, but it seems to be a habit with this lecture. Okay, so now let's look at this one. This one is a square. X squared is a square. 4 is a square. But this is to add. So this is the sum of two squares. All right. So let's talk about possibilities. Sometimes students will say, okay, I think this is x plus 2 squared. Now, that doesn't work if you do it correctly because this is a binomial and a binomial square is x plus 2 times x plus 2, which is x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. So this middle term is not what we're looking for. The reason that students kind of want this to work out is they incorrectly think that if I take x plus 2 and square it, I can just square these two and have x squared plus 4. But this process of just taking this square and applying it to what's inside only works if what you're dealing with is essentially a monomial. So if you had something like 2x squared, then yes, this 2 is squared, this x is squared. But this is a monomial because there's only one term, right? So for monomials, you can do that. If you had 3x, y, z, this would be squared. This would be 3 squared, x squared, y squared, z squared. All right. Pluses and minuses make space between terms. These are all times in here, so this is actually just one longer word than one longer word here. This is two terms. Here's the first term, here's the second term. This right here is space. Pluses and minuses make space. And if you have anything that's bigger than a monomial, that rule that works for monomials does not work here. So when things suddenly change, you're going, how come I can't do that? It probably went from you learned it as a monomial, and then now you're working with things that are bigger like binomials and trinomials and polynomials. And so that rule doesn't work anymore because it only works for monomials. All right. So x plus 2 squared is not x squared plus that. It's over here. X squared plus 4x plus 4. Likewise, if you had x minus 2 squared, you'd have x minus 2 times x minus 2 because it's a binomial, and you'd have to multiply it all out. And you'd have x squared minus 4x plus 4, which we're not looking for a minus 4x. And if you try to do this conjugate thing, you would have x squared minus 2x plus 2x minus 4. So you would have the difference of two squares. So what this boils down to is the sum of two squares, if it doesn't have anything in common, doesn't factor anymore. So this is prime. It does not factor. Remember, prime numbers are prime numbers that only have itself and 1 as a factor. So 7 is prime because its only factors are 1 and 7. It doesn't break down any farther. if you had 9, 9 is not prime because it has 3 times 3 in there as well. All right, so this does sum of two squares does not factor. However, look at this one. Does it factor? Now it is the sum of two squares. What do you think? Well, there's a 4 in common. So remember how I said if you train yourself to say, is there anything in common before you start looking for other patterns, that will save you some points here and there. So you would look at it and go, it's awful tempting to say it's the sum of two squares, but is there anything in common? Yes, there's a 4, right? So the fact that you can get out of 4 and that this results in the sum of two squares doesn't say that it doesn't factor. It factors a little bit. You can get this common 4 out, right? And it doesn't factor any further because this sum of two squares does not factor more, right? As opposed to this one that didn't factor at all. All right? So be careful. Now, let's look at this one right here. What if you have 16x to the fourth minus 81? And you go, okay, is there anything in common to factor out between a 16 and an 81? I don't think so. And there's no x in common. So let's look at maybe it's the difference of two squares. So it's definitely a difference, and there's a square on each end. So the square root of 16x to the fourth is 4x squared. And the square root of 81 is 9. And one's plus and one's minus, or minus plus. Okay, however you want to do it. Now, this factor right here, there's nothing in common to factor out that I might have missed between a 4 and a 9. 4x squared is still a square. 9 is a square. But this is the sum of two squares, so this factor does not factor any further. However, this one right here is the difference of two squares again. So a lot of times when you see this x to the fourth, they'll factor twice. All right, not always, okay? It just sort of depends. All right, now, so the square root, so I'm thinking this is going to factor again with conjugates, so the square root of 4x squared is 2x. Put it in the front. Square root of the 9, which is in the back, is 3, goes in the back. One's plus and one's minus. And this is the fully factored form. Okay, one more. Alrighty, so you go, well, that's kind of big. All right, now when you're going, especially into factoring, you should sort of be familiar with your squares and your cubes up to certain points. So like, 1 squared, 2 squared, 3 squared, 1, 4, 9. And most people kind of know those up to like maybe 11 squared is 121. But you really need to, I would say it'd be nice if you could get to 20 squared, but at definitely like 16. But once you get to 16 squared, you should go to 20 squared. So you should know all these squares. And then at least enough to recognize them, and then you can kind of play around to figure out, now wait, is that a 16 squared or an 18 squared? But you should recognize it as a possibility. Likewise, you should know your cubes. So, 1 cubed is 1, 2 cubed is 8, and you should know your cubes maybe down to like, usually they kind of stop at around 6 or 7 cubed because, it doesn't do too much. And the 4 is the same way. Maybe 1 to like 5, maybe something like that. 5 to the fourth. All right. So it wouldn't hurt you to get some flashcards and kind of write those down and work those up if you've forgotten them from before. Now, so 256 kind of rings a bell that it could be a square. I think it's a square, because I would have gone through my flashcards like this to figure out what it is. And 625, yeah, I think that's a square. All right. So we would have this kind of at least a familiarity with it to know we might want to stop and think about it. And after you think about it and kind of check either with your calculator on a piece of paper, you'll remember that 256, the square root of it is 16 because it was 16 squared. What did you square to get x to the fourth? X squared. What did you square to get 625? Okay, because 5 to the fourth is 625. So if 5 to the fourth is this, then 5 squared is the square root of this one. All right. And one's plus and one's minus. And so there's nothing in common between the 16x squared and the 25, but it is the sum of two squares, so it does not factor any further. The square root of 16x squared is 4x. The square root of 25 is 5. And one's plus and one's minus. And that is the complete factorization. All right. Now in the next video in this series, then we'll talk about the sum and difference of two cubes, and then a couple of more types, and then we'll be, I think it's like 3 more, and then we'll be done with factoring, the factoring part of this series. All right. So there'll be problems for you to practice in the description down below this video, and links to the previous videos and the next videos, and also in the problems for you to practice, I also give you complete worked out solutions. So be sure that you go and check those out and access them, and then don't forget to like and subscribe the video. All right, and I will talk to you later.